Hello everyone, welcome back. And in today's video, we are going to talk about a very interesting feature of Cosmos that you should be aware of if you're utilizing it. Because this feature will decide how much you're utilizing your Cosmos with respect to even cost. This is called partitioning. Today's talk, not this is called partitioning, but today's topic is called partitioning, and we'll define, we'll understand what partitioning is. Okay, so this is a very critical feature of Cosmos. Always remember this, because if you're talking about the Cosmos, the very first question the interviewer will ask is either partitioning or consistency level that we have already covered. Okay, and because of this feature, Cosmos is so powerful. And also how you can actually utilize it by creating a good partition key. Yep, partition key will create the partitioning, and we need to know what is a good partitioning key that we will cover in next video, because it requires a lot more videos or efforts to understand what is a good partitioning key, how you can choose a good partitioning key. But before we do that, let's try to understand what is partitioning, what is happening behind the curtain, what Cosmos is doing, and how we should think about partitioning and think how it should be done. Okay. So in Cosmos DB, till now, we have accomplished that we have container and we interact with container. We read the data from container, we write the data in the container. Basically, container is the service through which we interact, and we can store data in the container. Okay, now behind the scenes, these containers may have one or more physical machines attached to it to carry out the processes or query and things like that, right? That we, if you remember, we talked this structure a little bit in the horizontal scaling of Cosmos DB, right? So these physical machines are like a virtual machine, like the computer with their own CPU, storage, memory, and other resources. Okay, but this is managed by Cosmos DB. You can't see them, you can't logging into them, you don't know how many are running behind the scene, but as per structure, they are there. Okay, so if you add more data to the container, Cosmos will run more physical machine at the backend. Stay with me, do not get lost, stay with me. So till now we understood we are talking to the container, we are putting data inside the container, and at the back end there are machines running which is taking care of all those processing. Maybe you're requesting something, you're updating something. Processing power, the compute power, is at the back end physical machines, which is taken care by the Cosmos. Okay, so I'll share my screen once I'm through with this concept, so that once I go through the structure, it will repeat and this will get into your memory. Okay, so if you see between container and physical machine, there has to be something which is decided by the partition key, as we have mentioned a lot of time what partition key is, right? So there is this called logical partition that you can't see, but logically your data is divided into logical partition as per the partition key, and those logical partitions are mapped with the physical machines. So that if you see, the structure would be like container where the data is. Now you define the key, the partition key, which will partition the data into various logical partitions. And these logical partitions are mapped with the physical machines. It may possible you have more than one logical partition mapped with the physical machine, but it is not possible that a single logical partition is connected to more than one machine. Okay, this is very important because that's how you're going to define your partition key. You need to understand this. Single logical partition cannot be attached to more than one machine, but in one physical machine you could have more than one logical partitions. Okay, so what is partitioning? If I need to decide, if I have to define it, it is very simple now. Dividing the data set as per the partition key is partitioning. Like, let's put it in a simple words. Okay, and on the basis of logical partitioning is happening, that basis is decided by the partition key. Now let's take an example to understand all these key partition with the example, so that it will fit, it will connect the dots. Okay, so let's say we have user in Delhi. So all the data, it is more like, okay, let me share my screen and this will be helpful. Okay, all right, let me come here and quickly share my screen. If you see at the top, we have database that we have already talked about in previous video. That's the top level, and above it there is account that we have also seen. Under database we got containers right here. There are like two contain what I'm doing, there's two containers. And if you see at the bottom, there is a logical partition, and these logical partitions are connected to the physical partition, and these physical partitions are actually VM, or the virtual machines, or the compute power which is needed for this database. Okay, now these logical partition is happening on the basis of partition key. Now here you see the partition key is city. So what does that mean? That mean user data, all the users that belong to this particular city, for example, London, will come here. Users belong to New York will come in this logical partition. Paris people come here, and the Rome one will come here. Okay. Now, if you are deciding the partition key as airport, as per airport, for example, this lakhs, C and M's, these logical partitions are defined. Okay, so it's the logical partition is happening because of your partition key. You can think of anything. Let's think of social media. You can have these logical partition. If you, let's suppose you decided to have user ID as, because this is unique, right? So user ID as the partition key. So you would have that many logical partition, and that is okay. That is okay. As many logical partition you have, that is good. So partition key decide the logical partition, and these logical partition will be mapped with the physical machines at the back end. Okay. All right. Now let's expand this example of city. Let's say we have a user in Delhi. So all the data of these users will go into one logical partition, and data of all users in New York will go in separate logical partition, right? And so on. So we have a customer ID or customer name as a partition key as well. If we have customer ID as a partition key, which is unique, so all the customers will have their individual separate logical partitions, which are ultimately mapped to the physical partition. So this is what we have accomplished till now with the theory part, and repeat on the structure to so that this information would get into our memory. So as you see in the snippet, multiple logical partition is mapped to the single physical partition, and it's not like one logical partition is mapping to the multiple physical partition that I told you at the very beginning. Even in the structure that I have took from the Microsoft documentation shows the same thing, represents the same thing, okay? Now, if the size of the logical partition is small, physical partition can accommodate more than one logical partition. That is one of the reason you have multiple logical partition mapped with the physical partition. But if it is like the sizes keep growing of the logical partition and your physical partition is not able to cater that anymore, in that situation, because you might have multiple logical partition on that virtual machine, the compute, the Cosmos will move that logical partition, the one which is getting bigger, entirely to the different machine. It's not like half and half, it would be absolute. It would be entirely move that logical partition to the different machine. And this is all done by Cosmos behind the scenes, okay? So now if we have to define the partition key, it's very simple. We can define it with respect to partitioning. Well, I'm sorry, I just got a call. I was trying to put that on mute. So, well, partitioning is the items in a container divided into distinct subset of data called logical partition. And the key which divide the data is called partition key. Okay, logical partitions are formed based on the value of the partition key that is associated with each item in a container. If you remember the structure, there was account, database, container, and items. Item is the data set, the unit of the data there, like item. So once again, as I said, one logical partition cannot be divided into two physical partitions, but more than one logical partition can end up in one physical partition. It may possible Cosmos DB can change the location of your logical partition from one physical machine to another, but it will be absolute, like entirely it will change it. It will not be like 50-30%. Okay, so I hope you would understand. I would able to clarify the partitioning, partition key, logical partition, physical partition things. So if there is some confusion, you can watch the video again. It's very simple. And as I showed on the when I shared on the screen, it gives away everything. Like that's how it is, right? But even if you still have the confusion, you can, I'll share the link of Microsoft documentation in the description. You can go through that, or you can watch the video again. I'm pretty sure you'll get it. So let's meet in another video where we'll understand the various factors which plays a role in to decide the partition key. Okay, so till then, take care. Bye bye.